I need to find the exact solutions for the following cubic equation. X cubed minus 9x minus 10 equals 0. To do this, I need to at least break this down into a linear factor and a quadratic factor. So I'm going to test my roots here, and I'm going to test first of all plus minus 1. So when I test 1, I'm going to end up with 1 minus 9 minus 10. That's not equal to 0. I'm going to test negative 1. I'm going to end up with negative 1 plus 9 minus 10. Again, that's not equal to 0. Then I'm going to move on to 2, 5, etc. So testing 2, we're going to end up with 8 minus 18 minus 10. And it looks like negative 2 is going to work here. So I'm going to end up with negative 8 plus 18 minus 10, and that's going to be equal to 0. Okay, so I know that my factor is going to be x plus 2. Okay, so I have that so far. So what I want to then do is break down this polynomial, and I'm going to use synthetic division to do this. So I'm going to set up my synthetic division. I've got 1. I just have to make sure that I put in a spacer for the x squared, minus 9 minus 10. So I'm going to end up with negative 2, negative 4. So this works out to be negative 5. Negative 5 times 2 is equal to negative 10. And I get my remainder of 0. And again, if I don't get a remainder of 0, something's wrong with my factor. So now at this point, this is going to give me the quadratic factor of x squared minus 2x minus 5. And since this is all equal to 0, I have solutions at x equals negative 2. There's one solution. And my other solution has to come from that quadratic. Now, when I look at that quadratic, it's not factorable. So if I want to solve a non-factorable quadratic, I have to use my quadratic formula. So my quadratic formula, solving for x, I'm going to end up with negative b, so it's going to be positive 2 or negative 2, plus minus the square root of negative 2 squared minus 4 times a times c, which is negative 5. And that's going to be able to give me a positive discriminant. Okay, so I end up with 2 plus minus the square root of, this is going to work out to be 4 plus 20, or 24, all over 2. And this will simplify to 1 plus minus, if I factor the 4 out of here, I get the square root of 4 is 2, which cancels out, and I'm left with root 6 inside. So the x is going to be equal to negative 2, and then 1 plus minus root 6, or 1 plus root 6 and 1 minus root 6. The next example here, we're asked to find the value of k such that this has 2 real roots. Well, 2 real roots in a quadratic means that the discriminant must be greater than 0. So that means that b squared minus 4ac must be bigger than 0. So setting this up using these values, the b is going to be the k value. So I'm going to set this up as k squared minus 4 times a times c, and this must be greater than 0. So I end up with k squared minus, and this works out to be minus 40, is greater than 0. And solving for k, I get k squared is greater than positive 40. Okay, so when I solve this, the values of k that are going to give me numbers bigger than 40 are going to be when k is going to be greater than the square root of 40, or when k is going to be less than negative square root 40. For example, negative square root 41 will give me a solution for k. So my k is going to be plus minus, it's going to be bigger than root 40, positive root 40, and less than negative root 40. And this is based on the discriminant.